We have another test to talk about, and we're actually also going to expand on our definition of convergence to include something a little stronger, and that's the notion of absolute convergence. So, before we get into some examples with these alternating series, a special class of series, okay, we're going to have to develop some brand new definitions. And so, with that, we go ahead and begin. So we already know how to handle the convergence of a series, and of course, we know how to talk about the convergence of a corresponding sequence. But when it comes to when it comes to series whose terms alternate between pluses and minuses, or perhaps some are plus, some are minus, we need to strengthen our notion of convergence. And so we have this definition here called absolute convergence. So if I have a series, we say that the series is absolutely convergent, it exhibits absolute convergence if the sum of the absolute values converges. So let's go ahead and look at that here. Absolute convergence means that the sum of the absolute values converges. So all we do is we just take the absolute values of all the terms, add them up, and see what happens. Now, if we notice that that corresponding sum of absolute values does not converge, we say that the series is conditionally convergent, meaning the original sum converges, but the sum of absolute values does not. Okay. Now, this is actually a much stronger notion of convergence here. Okay. So we're going to go ahead and make a note here. This is stronger. So absolute convergence, if I get the right color pen here, absolute convergence is stronger. Okay, and what that means is if you have absolute convergence, you have the regular notion of convergence for free. And in fact, that's what this theorem down here below says. If a sum is absolutely convergent, then of course it converges in the regular sense. Okay, we're just extending our definition to include something a little stronger. Now, if you continue studying mathematics and look in analysis and the theory of infinite series, you'll get different notions of convergence. But for now, absolute convergence is the stronger one that you need to know. And now, with this in mind, we can talk about now the alternating series test. So, an alternating series is one where the terms alternate every single time between plus minus plus minus. And what makes this an alternating series? Well, an alternating series has this extra bit here, this minus 1 to the n plus 1, or minus 1 to the n, or even minus 1 to the n minus 1. Just we need that extra factor of negative 1 to some power, where the terms will end up flip-flopping. So here's what the corresponding test says. If I have an alternating series in one of these forms, okay, and I know something about this helper sequence Bn, okay, so this helper sequence Bn is pretty important to us. So what does this Bn do, okay? Well, this first condition says that it's positive and decreasing. So the helper sequence Bn needs to be positive and decreasing. And then we need to see if that Bn sequence has a limit 0. So let's write that down. Okay, some other ways that I can write that here, I can condense these into one notation to say that the limit, or rather, I can say that Bn decreases to 0. Okay, I'm not drawing an arrow to the right, but rather a downright arrow. That's just a way you can also compactly write this. But if you have this helper sequence that is positive and decreasing and has limit 0, then the corresponding alternating series is convergent, and that is called the alternating series test. Okay, so whenever I have an alternating series, I want to first ask the question, does the regular sum converge here? Okay, then that's the alternating series test. But I can ask a stronger question and think about absolute or conditional convergence. And in fact, we're going to be seeing a lot of that in the next video. Okay, so we now have the working definitions here, and we'll go ahead and look at the following examples in the next video. And I'll see you in the next one.